Thank you for joining us. Good morning, good afternoon. Today our presentation is about HighBay retrofits and some options that we all have been taking advantage of, as well as maybe some new options you had not heard of before. Before we get into that, let's talk about why we should get rid of these HID type lamps in the first place, so that we're all on the same page. We understand that these lights are very inefficient. The efficacy is extremely poor, especially if you look at means lumens over lifetime instead of initial lumens. As you can see here by the graph, they degrade quite quickly. If metal halide was held to the same standard as modern LED luminaires, it would be rated at L70 5,000 hours, where LED is rated at L70 50,000 hours for the most part. So the sheer power hungriness of this thing, and remember, a 400 watt HID lamp is running closer to 460 watts. The power for the ballast must be considered as well. For some reason, our industry has evolved that where fluorescent lamps, it considers the total sum of the lamp and ballast power consumption, but with HID, we just quote the lamp wattage. Also, the restrike period is very long. It's 7 minutes or so. I've heard of educational institutions, particularly those for grammar schools and younger students, where they're replacing the HID strictly for the reason, or primarily for the reason of restrike period. They consider it a life safety issue. If the light's power blips out for just a moment, they're 7 or so minutes in the dark. And then poor CRI, some of the worst that lighting has to offer. After low pressure sodium, which is pretty much finally out of the market, HPS is one of the lowest CRIs out there. It could be as low as 20 CRI, and metal halide generally about 60 CRI. So we're all agreeing that these have to go. Now, what are we going to replace them with? Before we get into the, I think, best options for those applications, let's talk about some that people have been talking about. LED, everyone's talking about LED, but in this application, 18, 23 foot ceilings, that's going to require 12,000 or so plus lumens. The efficacy of LEDs today, that is going to be 200 plus watts, and that's going to be a real heat issue. Keeping in mind that for the majority of LED luminaires today, they are either in temperature controlled environments such as office space and the like, or outdoor fixtures with controls that only have them powered on in the evening during the coolest part of the 24-hour period. In a warehouse application, that's very different. Usually at the peak of day they're on, usually not temperature controlled. I've worked in a few warehouses, never one that had temperature controlled environment. So there's some real obstacles for LED, but I think that the thermal properties of LEDs continue to expand and progress. That will be an application that LED will do a good job in, but certainly not today. Induction lighting. This is something that's been resurrected in the recent past, mainly due to the high cost of LED. Induction has been booming for a little bit of time in the recent past. We see it as a transitional technology because LED will both be higher efficacy and longer life eventually. The main issue that I have with induction is that it's not controllable. Can't be dimmed, can't be bi-level, at least not very well at all. And if you've been listening to our webinar series, you know that we're big believers in controls to maximize or minimize the length of time for that return on investment. Plasma lighting, which has had a buzz in the last couple of light fairs, and I've been tracking it for 4 or 5 years now, has made some inroads in the theatrical industry. But for a HighBay type application, there's weight issues, there's heat issues, there's cost issues. It's got a long way to go if it will ever work in that application. The primary light source for retrofitting HID into an energy efficient environment has been linear products, linear T8 and T5, 4 and 6 lamp fixtures for the most part. And this is what we're referring to as the old retrofit option. The product you see in the foreground, that is a high power CFL up to 200 watts. Here at MaxLight, we refer to it as the HiMax. And for those of you not familiar with this class of lighting, high power CFLs, they can do a great job in these applications as well. So let's talk about the pros and cons of each one. Starting with the high power CFL, hands down, it's the best uplight option. Certainly no linear type, T-Bay type fixture is going to give you the uplight that you have with the existing HID acrylic fixture retrofitted with a high power CFL, or a brand new, what we call dummy acrylic fixture, which has no ballast, nothing but a socket, hook and cord, ready to take your screw-in high power CFL. This gives a beautiful uplight, no cave effect, no tunnel effect. Even the linear fixtures with the slots for allowing uplight don't do a great job. It's almost a poor light shadow above the fixture generally, and it just sacrifices the light level coming down as well, as they punch holes in the reflectors to allow some light to go up. This high power CFL is the fastest return on investment in the business if you look strictly at the energy, going from 150 watts, from 450 plus watts down to 150 watts, and matching lumens. We'll demonstrate that a little earlier. The ROI is extremely short. Lowest cost buy-in in the industry. Typically for energy efficient fixtures, you pay more for the energy efficient than the older incumbent. That is not the case with this product. And as far as the install cost, you're basically bypassing the ballast and bringing the power directly to the socket and then screwing the bulb in. That's your retrofit job. Now here, let's take a look at this comparison. The comparison is showing 150 watt CFL with an inner reflector, compared to the 400 watt metal halide, which remember is about 450 watts. Starting in the left upper corner, in blue we have 36 foot candles, in red 38, virtually the same. The top right, 39 versus 33, so again virtually the same. Bottom left, 30 versus 37, bottom right, 39, 42, all within a few candles of each other. But I would like to draw your attention to the center point between the fixtures, where you'll notice that the HID falls short about 10 foot candles, about 30% in the farthest points from the fixtures, where by using the high power 150 watt CFL with its larger optic output combined with a very inexpensive and very cleverly made what we call inner reflector, which allows uplight and pushes the downlight into such a pattern that you get almost a 1-to-1 ratio across the floor, as you can see demonstrated in this slide. By the way, the ceiling height here was about 20 feet. The bottom is photographs before and after of the facility that was shown in the previous slide. This is a very large conference center in New York City. This was one of the 3 halls. Eventually, we retrofitted 2 of the 3 halls with a high power CFL. The third hall had 40-foot ceilings, and they're sticking with their 1,000 watt metal halides. There's still no good retrofit option for them. T5 didn't cut it, T5 6 lamp didn't cut it. Maybe T5 12 lamp would do it. But as far as I know, they're sticking with the metal halide today. Now, the top photo is a before and after going from HID to a linear HighBay. Now, back to the high power CFL. Here's a quick calculation of your payback, which clearly demonstrates less than 4-month return on investment. Now, all of you will get a copy of the spreadsheet where these formulas exist so that you can verify the numbers for yourself, as well as change the numbers to customize it for your particular application. So we're starting off with pretty modest 12 cents a kilowatt hour. We're assuming this job has 50 fixtures that need to be retrofitted. We're assuming a $80 per fixture cost of $4,000. We're putting in a 150 watt high power CFL versus a 400 watt metal halide. So our energy cost is $78.84 for the CFLs, $25,000 for the metal halide in the first year of usage, giving us a $17,000 savings. Now the maintenance here, which is first year only, because we have to install these fixtures, is at about $5,000. Maintenance for bulb changes on the metal halide about $1,500. That brings us down to the bottom line of about a $14,000 payback within 4 months. Again, the spreadsheet will be sent to you. You can see these numbers for yourself. I did say there's no faster ROI in the industry.